The air is cold, thick with the smell of cordite and burning wood. It's the dead of night, November 19th, 1940. Below, the city of London is a tapestry of fire, a hellscape orchestrated from above. Inside the glass nose of a Heinkel 111 bomber, the German crew is confident, almost arrogant. For them, this is routine. Flying at 12,000 feet, shrouded by the blackness of a new moon, they are ghosts, untouchable. The British fighters, the famous Spitfires and Hurricanes, are useless in the dark. They are lions, yes, but blind lions. The pilot, a young man named Hans, scans the sky. Nothing. The navigator checks his charts. Perfect. The bombardier releases his payload. Another direct hit on the docks. They turn for home. Another easy mission. Another nail in Britain's coffin. But then, something impossible happens. From out of the absolute, impenetrable black, a stream of cannon shells tears through their right wing. The engine explodes in a ball of orange flame. Hans wrestles with the controls, his mind reeling. Where did it come from? There were no searchlights, no telltale glow of another aircraft's exhaust. It was as if a phantom had reached out of the void and swatted them from the sky. As the Heinkel spirals down towards the very city, it was just bombing. The last thing the crew hears is the roar of an engine they never saw, the sound of a hunter that stalks the darkness. This was not a lucky shot. This was not a fluke. This was the birth of a new kind of warfare, a secret weapon the Luftwaffe didn't even know existed. And for hundreds of German air crews, the first sign of this weapon would also be their last. On the other side of the English Channel, the mood was one of quiet desperation. For the pilots of RAF Fighter Command, the night was a terrifying, frustrating enemy. Every evening as the sun set, a feeling of helplessness would descend upon the airfields of southern England. They would hear the drone of the German bombers, a relentless, guttural sound that filled the sky. They would see the glow of the fires in London, a city being torn apart, night after night. And they could do almost nothing about it. A pilot could be scrambled, climbing into his Hurricane, his engine a reassuring roar in the cold night air. Ground control would give him a rough vector, a guess based on sound detectors that looked like giant concrete ears, or the primitive plots from the chain-home radar stations along the coast. Bandit estimated over Maidstone, Angels 10, a voice would crackle in his ears. 10,000 feet. He would push his plane into the blackness, his eyes straining, searching for a shadow against the stars, a flicker of an exhaust flame. But the sky is vast, an ocean of darkness, and a bomber is a tiny speck within it. It was like trying to find a single black cat in a coal cellar, with the lights off. Pilots would fly for hours, burning precious fuel, chasing ghosts, their necks aching from scanning the void. They would see the flashes of anti-aircraft fire below, a useless and inaccurate defense that mostly just threw metal into the sky. More often than not, they would land again, exhausted and defeated, having seen nothing, fired no shots, while the bombs continued to fall. The public saw them as heroes of the Battle of Britain, the saviors of the daytime skies. But at night, these same pilots felt like failures. The existing tactics were a joke. Searchlights would try to illuminate a bomber, but the Luftwaffe pilots quickly learned to fly above them or use cloud cover. The sound detectors were wildly inaccurate, often fooled by the wind. The early ground radar could tell you something was coming, but it couldn't guide a fighter with enough precision for an interception. Britain was winning the war in the daylight, but it was losing badly in the dark. The morale of the country was cracking, and the top brass at the Air Ministry knew they needed a miracle. They couldn't see the enemy. They needed to give their pilots a new kind of eyes. The miracle they needed wasn't born in a factory or on a military drawing board. It began in the quiet, wood-paneled rooms of British universities, with a group of men who were more comfortable with slide rules than machine guns. These were the Boffins, a slightly mocking but affectionate term for the scientists and engineers who were waging a different kind of war. Their leader was a man named Henry Tizard, a brilliant chemist and strategic thinker. Years before the war, in 1934, Tizard had a chilling realization. The next war would be fought in the air, and Britain, an island nation, was terrifyingly vulnerable to bombers. He chaired a top-secret committee to explore new methods of air defense. They looked at all sorts of wild ideas, from giant death rays to balloons trailing wires, to snag propellers. But one idea, proposed by a quiet, unassuming radiophysicist named Robert Watson Watt, seemed just crazy enough to work. He called it RDF, or radio direction finding. The name was deliberately boring to hide its true purpose. The concept was simple, almost like an echo. You send out a powerful pulse of radio waves. If it hits something solid, like an airplane, a tiny fraction of that energy will bounce back. By measuring the time it takes for the echo to return, you can calculate the distance to the target. It was a revolutionary idea. By 1939, Watson Watt and his team had built a string of enormous radar towers along the south and east coasts of England. This was Chain Home, Britain's electronic shield. It could see German bombers massing over France long before they reached the English coast, giving Fighter Command precious minutes to get their Spitfires and Hurricanes into the air. Chain Home was the system that won the Battle of Britain. But it had a fatal flaw. It was a sledgehammer, not a scalpel. It could tell you a raid was coming, and roughly where, but it wasn't nearly accurate enough to guide a single fighter onto a single bomber in the vast darkness of the night sky. The Boffins had given Britain eyes, but those eyes were blind in the dark. The problem was clear. The radar couldn't just be on the ground. It needed to be in the air. It needed to be small enough, light enough, and powerful enough to fit inside the fighter itself. The challenge was immense. They needed to shrink a system that required 300-foot steel towers and buildings full of equipment into a box that could fit in a two-seater airplane. To almost everyone, it sounded impossible. The man tasked with achieving this impossibility was Edward Taffy Bowen, a Welsh physicist with boundless energy and a knack for practical engineering. Bowen was one of Watson Watt's star pupils. He was a pioneer, a man who saw no difference between a scientific problem and a physical adventure. He was as comfortable flying a test plane as he was soldering a circuit. In 1936, long before the Blitz, Bowen was already thinking about putting radar on a plane. His team started with what they had, the technology from the Chain Home ground stations. The problem was the wavelength. Chain Home used very long radio waves, around 10 meters. To get a good echo from a plane, you needed a massive antenna, far too big to mount on a fighter. Bowen knew he had to use much shorter wavelengths, around 1.5 meters. This would allow for smaller, more compact antennas. The work was done in absolute secrecy at a remote research station in Bawdsey Manor, a Gothic-looking estate on the Suffolk coast. It was a strange place for the birth of a revolution. Scientists in tweed jackets worked alongside RAF mechanics in greasy overalls. They cannibalized parts from commercial radios and televisions, working long hours fueled by tea and sheer determination. Their first attempts were clumsy. They mounted a prototype in an old, slow bomber, a Handley Page Hayford. The plane was a flying laboratory, crammed with humming electronics, flickering screens, and a web of wires. The cockpit was so drafty that the scientists had to wear ski gear to keep from freezing at altitude. The early radar sets were a nightmare. The vibrations from the engines would shake components loose. The electrical systems of the plane would create so much interference that the radar screen was just a useless blizzard of green static, what they called grass. The operators would get sick from staring at the flickering cathode ray tube for hours on end. There were countless failures. Tests that yielded nothing. Flights where the equipment simply died mid-air. But slowly, painstakingly, they began to get results. A faint blip on the screen. An echo from a passenger plane flying nearby. A glimpse of a ship in the channel below. Bowen himself often flew as the test operator, scribbling notes in the freezing cold, convinced they were on the verge of a breakthrough. He knew that if they could just make it reliable, if they could make it work every time, they could turn the night from a shield for the enemy into a hunting ground for the RAF. The road from a flickering prototype in a drafty bomber to a reliable weapon of war was long and frustrating. The first version, logically named Airborne Interception Mark I, was a monster. It was heavy, unreliable, and its maximum range was barely 2 miles, often less. It was more of a scientific curiosity than a weapon. The Mark II was a slight improvement, but it was still plagued by technical gremlins. Then came the Mark III. This version showed real promise. Taffy Bowen and his team had managed to iron out many of the bugs. The range was better, and the display was clearer. They were ready to test it in a proper fighter. But which one? The Spitfire was too small and nimble. There was no room for the bulky radar equipment and a second crew member to operate it. The Hurricane was a rugged workhorse, but it also lacked the space. They needed something new. A plane that was fast, powerful, and, crucially, had room for a pilot, a dedicated radar operator, and nearly 70 kilograms of secret black boxes. The answer came from the Bristol Aeroplane Company. It was an aircraft that looked brutal, almost menacing. A twin-engine, two-seat heavy fighter called the Beaufighter. It was a perfect match. Its 2 Hercules engines gave it the power to carry the heavy radar set and a devastating amount of firepower. 4 20mm cannons in the nose and 6 machine guns in the wings. It was stable, a solid gun platform, and had a fuselage with just enough space to cram in a radar operator behind the pilot. The Beaufighter was nicknamed the Whispering Death by the Japanese later in the war, but in 1940, for the Luftwaffe, it would become the Silent Killer. The arrival of the Beaufighter was a critical piece of the puzzle. Now, the scientists had a platform, but the technology was still raw. The Mark III radar was good, but it had a blind spot. Its minimum range was about 1,000 feet. This meant that as the fighter closed in for the kill, the target would disappear from the screen. The pilot would be blind again for the final, crucial seconds of the attack. They had to find the bomber in the dark with their own eyes. For the system to truly work, they needed one more evolution, the Mark IV. This new set incorporated a more advanced transmitter and receiver, and critically, a better display system. It was simpler, more reliable, and just powerful enough to do the job. By the summer of 1940, as the Battle of Britain raged in the daytime skies, the first Beaufighters fitted with AI Mark IV radar were secretly rolling off the production lines. The weapon was ready. Now, they needed the warriors to wield it. The new weapon created a new kind of warrior. The dashing lone wolf fighter pilot of the daytime battle was not the right fit for this new, dark war. Night fighting was a team sport, a strange and intimate partnership between 2 men, locked together in a cramped metal shell, hurtling through the pitch-black sky. In the front sat the pilot, his job to fly the aircraft smoothly and accurately, trusting a voice in his headset completely. Behind him, hunched over a small, glowing screen, was the man who held both their lives in his hands, the radar operator. His world was not the sky outside, but the abstract, flickering green line on his cathode ray tube. He was the eyes of the aircraft. For these new roles, the RAF looked for a specific type of person. Pilots needed to be steady and methodical, not hot-headed aces. They had to be able to fly precisely on instruments, trusting their gauges and not their senses, which could play cruel tricks in the disorienting darkness. The radar operators were a new breed entirely. Many were not professional aircrew. They were physicists, engineers, and radio technicians, men who understood the strange new science of radio waves. They were often older, more academic than the young pilots they flew with. Their training was intense and highly secret. They would sit for hours in darkened trailers on the ground, learning to interpret the strange dance of light on their screens. A returning radio echo from a bomber didn't look like a plane. It appeared as a blip, a small spike of light on a horizontal line. The operator had to interpret what this blip was telling him. By watching how it moved, he could guide the pilot. "Turn port, steady, steady. You're closing. He's slightly above you. Throttle back now." It was a constant stream of calm, precise instructions. The two men had to develop an almost telepathic understanding. The pilot had to trust the operator's voice implicitly, even when it told him to fly in a direction that felt wrong. The operator had to translate the cold, electronic data from his screen into commands a pilot could follow. This partnership was best exemplified by the most famous night fighter crew of the war, pilot John Cat's Eyes Cunningham and his radar operator, Sergeant Jimmy Ronsley. Cunningham was already known for his supposedly phenomenal eyesight, a useful piece of propaganda the RAF encouraged to hide the real secret. In reality, his greatest asset was Ronsley, sitting behind him, calmly interpreting the blips, guiding him through the darkness to a target he couldn't see, turning the abstract green spike into a doomed German bomber. They were a perfect team, a fusion of man and machine that would become the blueprint for all night fighter crews to come. Before the secret weapon could be unleashed, it had to be integrated into a larger system. An airborne radar on its own was still not enough. The sky was just too big. A Beaufighter crew could take off and fly around all night and never come within the radar's 10-mile range of a German bomber. They needed to be guided to the right patch of sky first. This is where the ground controllers came in. The British had been developing a new type of ground radar, different from the early chain-home system. It was called GCI, for Ground-Controlled Interception. These GCI stations had a revolutionary new feature, a rotating antenna. This meant they could see the entire sky around them, 360 degrees, in real time. Inside a dark, underground bunker, a team of controllers, many of them women from the WAF, Women's Auxiliary Air Force, would watch the results on a circular screen called a Plan Position Indicator, or PPI. The PPI looked like a modern air traffic control screen. Friendly aircraft appeared as blips of light, and enemy bombers appeared as others. The GCI controller was the conductor of the orchestra. They would watch a blip representing a Heinkel or a Dornier drone its way across the screen. Then, they would vector a nearby Beaufighter towards it. Using radio, the controller would give the pilot a series of headings and altitudes. Vector 190, Angels 15. This would get the Beaufighter into a position a few miles behind the bomber, a position they called the contact sphere. Once the fighter was in the vicinity, the ground controller would hand over the operation. "Tally-ho, contact ahead. Your control now." At this point, the radar operator in the Beaufighter would switch on his AI set and begin his own search. He would scan the darkness with his electronic eyes, looking for the telltale blip that meant the hunter had found its prey. This two-stage process was the key to the entire system. GCI was the wide net, finding the enemy in the vastness of the sky. The AI radar was the spear, allowing the fighter to close in for the final, deadly attack. It was a complex and delicate dance, requiring perfect coordination between the ground and the air. When it worked, it was lethally effective. And in the late summer of 1940, the system was finally ready for its first real test. The hunters were in the sky, the controllers were watching their screens, and the German bombers were on their way, completely unaware that the rules of the night war were about to change forever. The night of July 22nd, 1940. The Blitz had not yet begun in earnest, but lone German bombers were already probing Britain's defenses, flying nuisance raids. On this night, a Dornier 170 bomber was droning its way over Sussex. Its crew was relaxed, confident in the cloak of darkness. Below, at RAF Tangmere, a Beaufighter from the newly formed Fighter Interception Unit was ordered to scramble. At the controls was Flying Officer G.E. Ashfield. Behind him, peering into the green glow of his radar screen, was his operator, Pilot Officer G.E. Morris. On the ground, a GCI controller watched the two blips of light converge on his screen. He gave Ashfield a series of calm instructions, guiding him through the black sky. Finally, he gave the word they were waiting for. The Dornier should be right in front of them, just a few miles away. Morris, in the back, leaned forward, his eyes glued to the screen. And there it was, a tiny, faint spike, a ghost. "Contact!" he called out over the intercom, his voice steady despite the adrenaline. "Contact. Dead ahead. Range 4 miles." Ashfield held the Beaufighter steady, his own eyes seeing nothing but blackness. He was flying completely on the instructions of the man behind him. "Range 3 miles. Closing nicely," Morris reported. "Slightly above us. Go up 200 feet." Ashfield nudged the nose of the heavy fighter up. The tension in the cockpit was immense. This was not a drill. This was the moment everything, all the years of research, all the failed experiments, all the training, had been leading up to. 2 miles, 1 mile. "He's drifting slightly to starboard." Ashfield made a gentle turn. "Half a mile, 800 yards. You should see him soon." Ashfield strained his eyes, peering through the armored glass of the windscreen. And then he saw it. A dark shape, a silhouette blacker than the surrounding sky. The unmistakable twin-tailed shape of a Dornier. It was exactly where Morris said it would be. He felt a surge of triumph. The machine worked. He eased the Beaufighter closer, lining up the bomber in his gun sight. He was just over 200 yards away when he pressed the firing button. 4 20mm cannons erupted in a deafening roar, spewing a torrent of explosive shells. The effect was devastating. He saw chunks fly off the Dornier's fuselage. A bright flash, and then a fire started in its port engine, a long, ugly tongue of flame. The bomber lurched violently and began to fall, spiraling down into the darkness. It was the first confirmed kill using airborne radar. A new chapter in aerial warfare had been written in the skies over Sussex. The secret weapon was no longer a theory. It was a proven killer. The first kill was a moment of triumph, but it also created a massive problem for the Air Ministry: how to keep it a secret. If the Germans found out that the RAF had a working airborne radar, they would immediately start developing countermeasures. They would fit their bombers with warning receivers. They would develop jamming technologies. And worst of all, they would start building their own version for their night fighters. The secret of AI radar was, at that moment, more valuable than an entire wing of Spitfires. An extraordinary level of secrecy was immediately put in place. The technology was classified most secret, a level higher than top secret. The scientists and engineers who worked on it were forbidden from discussing their work with anyone, even their families. The radar sets themselves were fitted with explosive, self-destruct charges. Pilots and operators were given strict instructions. If their plane was going down over enemy territory, their absolute last act must be to trigger the destruct charge to prevent the technology from being captured. Their own survival was secondary. A cover story was concocted to explain the sudden increase in nighttime kills. The press was fed stories about pilots with exceptional night vision. Pilots like John Cunningham were publicly nicknamed Cat's Eyes, and the Ministry of Information even circulated rumors that the pilots were eating huge quantities of carrots to improve their eyesight. It was a brilliant piece of disinformation, simple and believable. The public loved the idea of these superhuman aces, and the Germans, for a time, bought it. They found it more plausible that the British had a handful of pilots with freakishly good vision than it was that they had solved the monumental technical challenge of putting radar in a fighter plane. The night fighter crews themselves were part of the deception. If they were shot down and captured, they were instructed to stick to the carrot story. They were to feign ignorance of any special equipment. This secrecy created a strange, isolated world for the men who flew the Beaufighters. They were performing incredible feats of arms, night after night, but they could not share the true reason for their success with anyone outside their small, closed circle. They were fighting a war within a war, one in the sky against the Luftwaffe, and another on the ground against German intelligence. For now, the secret was safe. The German bombers continued to fly their nightly missions, oblivious to the invisible web being woven around them. Meanwhile, in a plush office in Berlin, the head of the Luftwaffe, Hermann Göring, was receiving glowing reports. His bombers were pounding London with impunity. His intelligence chief for the air war against Britain, a man known as Joseph Beppo Schmid, was feeding him exactly what he wanted to hear. Schmid's reports painted a picture of an RAF on the verge of collapse. He assured Göring that British night defenses were primitive and ineffective. When reports of German bombers being shot down at night began to trickle in, they were dismissed. Schmid and his analysts attributed the losses to a variety of causes: mechanical failure, freak weather conditions, lucky shots from anti-aircraft guns, or the rare, unlucky encounter with a British fighter on a moonlit night. The idea of a systematic, technology-based defense system was never seriously considered. The German mindset was part of the problem. They were pioneers in many areas of military technology, but their own attempts at developing airborne radar had been slow and inconclusive. Their leading electronics firms had told the Luftwaffe High Command that a compact, effective airborne radar was years away, perhaps impossible with current technology. Therefore, they projected their own technical limitations onto the enemy. If they couldn't do it, surely the British couldn't either. This was a classic intelligence failure, born of arrogance and a lack of imagination. They had captured wreckage of British planes, but none of the early night fighters had crashed in occupied territory. They interrogated captured RAF pilots, who dutifully told them stories about eating carrots. German radio listening services picked up strange signals, but they couldn't decipher their purpose. Schmid's intelligence agency was good at counting enemy squadrons and assessing bomb damage, but it was completely blind to the technological revolution happening just across the channel. They were fighting a 20th century war, but they were thinking in 19th century terms. This blindness would prove catastrophic. While Schmid was reassuring his superiors, the RAF was quietly building up its night fighter force. More Beaufighters were rolling out of the factories. More crews were completing their secret training. The cat's eyes myth was working perfectly, lulling the Luftwaffe into a false sense of security. Every night, the German bomber crews climbed into their planes, confident that the darkness was their ally. They had no idea they were flying into a carefully laid electronic trap. Building a handful of prototype night fighters was one thing. Creating a force capable of defending the entire nation was another challenge altogether. In the autumn of 1940, as the Blitz intensified, the pressure was on to scale up the new system. The first operational squadron to be fully equipped with radar-equipped Beaufighters was No. 2 19 Squadron, based at RAF Tangmere. They were followed by other famous units, like No. 604 County of Middlesex Squadron and No. 85 Squadron. These were the pioneers, the first to turn the theory of night interception into a nightly, lethal reality. The challenges were enormous. First, there was the problem of production. The Beaufighters themselves were complex aircraft, and the Bristol factories were working around the clock. But the real bottleneck was the secret black boxes of the AI Mark IV radar. These were delicate, hand-built pieces of high technology. Skilled technicians were in desperately short supply. Each set had to be individually installed, calibrated, and tested, a process that could take days. Then, there was the human element. Training enough crews was a monumental task. Pilots had to unlearn their instincts to rely on their eyes and learn to trust their instruments and the voice in their headset. Radar operators had to be recruited from civilian life, men with backgrounds in physics or radio, and turned into combat aircrew in a matter of months. They trained in specially modified aircraft, learning their trade by tracking friendly planes in mock interceptions. The pressure was intense. Every night, the air raid sirens would wail over Britain's cities. Every morning, the newspapers would report the terrible damage. The men of the new night fighter squadrons knew that they were the country's only real hope of stopping the slaughter. Life on these squadrons was a strange mix of boredom and terror. The crews would wait for hours in chilly readiness huts at the edge of the airfield, playing cards, reading, or trying to sleep, always dressed in their full flying gear. Then the phone would ring, the scramble bell would sound, and they would sprint to their aircraft. Within minutes, they would be climbing into the cold, dark sky, their fate now in the hands of the GCI controller, on the ground, and the flickering blips on a small green screen. It was a slow, painstaking process, building this new force one plane, one crew at a time. But with every new Beaufighter that joined the line, with every new crew that passed its training, Britain's shield against the night bomber grew a little stronger. November 14th, 1940. The German code word for the night's operation was Moonlight Sonata. The target was the city of Coventry, a major industrial center in the heart of England. It was a raid planned with devastating precision. Over 500 Luftwaffe bombers were sent in waves, guided by a sophisticated system of radio beams called X-Jurat. For 11 hours, they systematically pounded the city, dropping a horrific mix of high-explosive bombs and thousands of incendiary devices. The result was a firestorm that consumed the medieval heart of the city, destroying its famous cathedral and killing or injuring over 1,000 civilians. The Coventry raid became a symbol of the Blitz's brutality. From the German perspective, it was a stunning success. But for the RAF's fledgling night fighter force, it was a frustrating and bloody education. That night, 125 defensive sorties were flown by British aircraft. But the night fighter system was still in its infancy. There were not enough Beaufighters to go around. Many of the planes sent up were older, slower aircraft, like the Bolton Paul Defiant, which were largely ineffective. The GCI network was overwhelmed by the sheer number of enemy bombers. Controllers struggled to distinguish individual targets in the mass of blips on their screens. Despite the chaos and the overwhelming odds, the radar-equipped fighters did manage to fight back. A Beaufighter from the Fighter Interception Unit, flown by the legendary John Cunningham, with Jimmy Ronsley as his operator, found a Heinkel 111 caught in a searchlight beam. Cunningham poured a burst of cannon fire into the bomber, which exploded in midair. It was a small victory in a night of overwhelming defeat. Only one German bomber was confirmed shot down for certain that night, with a couple more probables. It was a drop in the ocean compared to the size of the attacking force. The destruction of Coventry was a grim lesson. It showed that having a new technology was not enough. It had to be deployed in sufficient numbers, with well-trained crews and a control system that could handle a massive, coordinated attack. The raid was a tragedy, but it also stiffened the resolve of the Air Ministry. It redoubled the efforts to produce more Beaufighters, train more crews, and expand the GCI network. The hunters were learning. They had been bloodied and beaten, but their secret weapon had worked, even amidst the chaos. They knew that next time, they would be stronger. While the night fighters were learning to use their new electronic eyes, Another, even more secret electronic war was being waged. The German bombers weren't just flying aimlessly in the dark. They were being guided to their targets with incredible precision by a series of radio beams. This was the Battle of the Beams. The Germans had developed several systems. The first was called Knickebein, or crooked leg. It used two radio beams, transmitted from stations in occupied Europe. The bomber would fly along one beam, which would give it the correct course. A second beam would intersect the first one directly over the target. When the pilot heard the signal from the second beam, he knew it was time to drop his bombs. It was simple and brutally effective. British intelligence, however, was not idle. A brilliant scientist named R.V. Jones, working for the Air Ministry, suspected the existence of these beams. By analyzing crashed German bombers and using specially equipped reconnaissance aircraft, he figured out how the system worked. Once they understood it, they could fight it. The British developed a countermeasure that was elegantly simple. They transmitted their own radio signals on the same frequency as the German beams. These signals, codenamed aspirin, were designed to disrupt or bend the German guidance beam, causing the bombers to drop their payloads harmlessly in open countryside. The Germans responded by developing a more complex system called X-Jarrett, which used multiple beams for even greater accuracy. The British, in turn, developed jammers for that. This back and forth was a high-stakes chess game played with radio waves. It was a war fought by physicists and engineers, a silent battle that was just as crucial as the dogfights in the sky. For the night fighter crews, this electronic warfare had a direct impact. A bomber that had been thrown off course by a bent beam was often isolated and easier to find. Furthermore, the British mastery of German radio frequencies gave them an invaluable intelligence edge. They could listen to the German bomber crew's radio chatter, giving them advance warning of where the night's raid was heading. The AI radar in the Beaufighter was the glamorous, sharp end of the technology. But it was supported by this vast, invisible network of signals intelligence and electronic countermeasures. It was a complete system. The British weren't just learning to see in the dark. They were learning to control the very airwaves the enemy depended on. As the winter of 1940 turned into the spring of 1941, one name became synonymous with the success of the night fighters: John Cunningham. His official score of victories kept climbing, and the Cat's Eyes legend grew with it. He became a national hero, the poster boy for the defense against the Blitz. But the real story was the quiet, methodical partnership in the cockpit of his Beaufighter. Cunningham was an exceptional pilot, cool-headed and precise. He had a natural talent for instrument flying and a deep understanding of his aircraft. But his real weapon was the man sitting behind him, Sergeant Jimmy Rawnsley. Rawnsley was the master of the little black box. He had an uncanny ability to interpret the flickering green blips on his screen. While other operators might lose a contact in the electronic clutter near the ground, Rawnsley could follow the faintest of echoes. Their process became a deadly routine, honed over dozens of missions. Guided by a GCI controller, Cunningham would get them into the target area. Then, Rawnsley would take over, his calm voice a constant presence in Cunningham's ears. Contact, port 10 degrees, range 3 miles. Cunningham would begin a gentle turn, never too sharp, to keep the bomber within the narrow cone of the radar beam. Steady, closing. He's a little above us. Cunningham would climb slightly. Rawnsley would provide a running commentary, giving range, bearing, and altitude adjustments. For Cunningham, it was an exercise in pure trust. He was flying blind, his world reduced to his instruments and Rawnsley's voice. They developed their own shorthand, their communication becoming clipped and efficient. They flew together so often that they could anticipate each other's actions. The final moments were always the most tense. As they closed to within 1,000 feet, the bomber would disappear from Rawnsley's screen. Should be dead ahead now, John. You're visual. This was Cunningham's cue. He would peer into the blackness, his eyes now fully adjusted to the dark. He knew exactly where to look, and almost every time, there it was. The dark, solid shape of a German bomber, sailing along, completely unaware of the phantom stalking it from behind. Cunningham would make his final adjustments, close to point-blank range, and then unleash the Beaufighter's devastating firepower. For them, it was a job. A difficult, dangerous, and precise job. They were the perfect embodiment of the new warfare. One man to fly the plane, one man to aim the weapon, a seamless fusion of human skill and revolutionary technology. Why did the Germans remain blind for so long? The answer lies in a cocktail of arrogance, flawed intelligence, and a failure of imagination. At the very top, Hermann Göring refused to believe that the British could have developed a technology that his own experts had deemed impossible. He was a man who believed in the power of German willpower and aggression, not in the subtle arts of electronic warfare. Any evidence that contradicted his worldview was simply dismissed. His intelligence chief, Beppo Schmid, continued to feed him reports that confirmed this bias. Schmid's agency was convinced the rising RAF success was due to the Helle Nachtjagd, or illuminated night fighting procedure. This was a system where ground radar and searchlights would attempt to illuminate a bomber, which could then be attacked by fighters. This system did exist, and it did occasionally work, so it provided a convenient and plausible explanation. It allowed the Germans to believe the British were simply getting better at using conventional, understandable tactics. Not that they had made a quantum leap in technology. They saw what they wanted to see. There were clues, of course. German bomber crews who survived being attacked at night often reported the same bewildering experience. They were attacked out of a perfectly black sky with no warning. But these reports were often discounted. The stress of combat can play tricks on the mind after all. Who could trust the testimony of a terrified crew whose plane had just been shot to pieces? Furthermore, the German electronics industry was focused on offensive capabilities, like the guidance beams for their bombers. Defensive technologies, like radar warning receivers, were a lower priority. There was a fundamental belief that the bomber would always get through. The Luftwaffe was an attacking force, and its institutional mindset was geared towards offense, not defense. This combination of factors created a fatal blind spot. The British carrot and eyesight propaganda was so effective because it played into this German mindset. It was easier for them to believe in a few superhuman enemy pilots than to accept that their entire strategic bombing campaign was being systematically dismantled by a secret weapon they didn't understand. By the time they finally woke up to the truth, it would be far too late. Hundreds of their bombers and thousands of their experienced aircrew had already paid the price for their ignorance. For the crews of the Beaufighters, life was a surreal existence, a cycle of long, tedious waits punctuated by brief moments of heart-stopping action. Their war was fought in darkness and isolation, a world away from the great daylight air battles of the previous summer. An operational night for a crew would begin in the late afternoon with a briefing. They would study weather charts and intelligence reports on likely German targets for the night. Then came the waiting. They would gather in the squadron's dispersal hut, a small wooden building near their aircraft. They would try to relax, to push the thought of what was to come out of their minds. They drank endless cups of tea, read worn paperbacks, wrote letters home, or played cards. The tension was a low hum in the background, a knot in the stomach that never fully went away. They lived in their heavy flying gear, the bulky sheepskin jackets and boots, ready to go at a moment's notice. The sound they all listened for was the telephone. A sharp ring would cut through the quiet chatter, followed by the order to scramble. From that moment, everything was a rush of controlled chaos. The two men would run out into the cold night, the roar of another Beaufighter's engines already splitting the air. They would climb into their cramped cockpit, the pilot up front, the operator squeezing into his small station behind. The pre-flight checks were a quick, memorized ritual. Then, the Hercules engines would cough into life with a cloud of blue smoke. They would taxi out onto the dark runway, guided only by a few dim lights, and then launch into the blackness. Once airborne, a strange calm would descend. They were alone in their own small world. The glow of the instrument panel, a tiny island of light in an ocean of darkness. For the next 2 or 3 hours, they would be connected to the ground only by the crackling voice of the GCI controller. The hunt was a slow, methodical process, often ending in frustration. For every successful interception, there were many more flights where they found nothing, returning to base as the first hints of dawn were breaking, tired and empty-handed. But when it did work, when the operator found a contact and guided them in, the psychological toll was immense. Stalking another aircraft in the dark, closing in, and then violently destroying it, was a brutal, impersonal, yet intensely personal act. These men were pioneers of a new, lonely kind of war. By mid-1941, the Beaufighter had proven its worth, but the Boffins were already working on its successor. Technology in wartime moves at a blistering pace, and the British knew they had to stay one step ahead. The next great leap forward came not from a traditional aircraft manufacturer, but from a company famous for building elegant wooden furniture and pianos, de Havilland. Their creation was a masterpiece of aeronautical design, an aircraft that would become a legend, the Mosquito. The Mosquito was a radical concept. In an age of all-metal warplanes, it was built almost entirely of wood, spruce, birch plywood, and balsa, all held together with a special glue. This made it incredibly light, strong, and crucially, very fast. It was also virtually invisible to the Germans' own early radar systems, earning it the nickname, the Wooden Wonder. The Mosquito was originally designed as a fast, unarmed bomber, relying on its sheer speed to evade enemy fighters. But the RAF quickly realized its potential as a night fighter. The fighter version, the NF Mark II, was fitted with an updated AI Mark V radar and the same deadly armament of 4 cannons and 4 machine guns as the Beaufighter. But it had one huge advantage: performance. The Mosquito was significantly faster than the Beaufighter and could fly much higher. As the Germans introduced newer, faster bombers, the Mosquito had the speed to catch them. Its high service ceiling allowed it to intercept high-altitude raiders that the Beaufighter struggled to reach. Flying the Mosquito was a different experience. It was a thoroughbred, light on the controls, and incredibly responsive. For the pilots, transitioning from the heavy, brutish Beaufighter to the nimble Mosquito was like trading a truck for a sports car. The arrival of the Mosquito on the night fighter squadrons in late 1941 marked the beginning of a new phase. The British were no longer just defending their own skies. The speed and range of the Mosquito allowed them to take the fight to the enemy. They could now fly intruder missions, crossing the channel to patrol over German-occupied airfields, ambushing enemy bombers as they took off or landed. The hunter was no longer waiting in its own territory. It was now stalking the prey in its own lair. As the British went on the offensive with the Mosquito, their scientists provided them with a new set of electronic claws. The Germans, having finally realized they were facing a radar-guided defense, had been forced to develop their own night fighters equipped with airborne radar. Their system was called Liechtenstein. Now German night fighters like the Messerschmitt 110 and the Junkers 88 were prowling the skies over the Reich, waiting for the RAF's bombers. The cat-and-mouse game had reached a new level. The British needed a way to counter the German night fighters. The answer was a clever device codenamed Serrate. Serrate was not a radar. It was a receiver. It was designed to listen for the specific radio frequencies used by the German Liechtenstein radar. A British Mosquito equipped with Surratt could detect the transmissions from a German night fighter long before the German crew knew they were there. The Surratt display was a simple cathode ray tube that showed the British crew the bearing of the German fighter's radar emissions. The Mosquito crew would see a splash of light on their screen, and they would know, there's a hunter out there. And then, they would turn the tables. They would use the Surratt information to stalk the German fighter. It was a reversal of roles. The British, who had invented the art of radar-guided night interception, were now using the enemy's own emissions to hunt them down. These missions were incredibly dangerous. A Mosquito crew would deliberately fly into areas where they knew German night fighters were operating. They were the bait and the trap all in one. The pilot would follow the bearings from the Surratt device, while the radar operator would scan ahead with their own AI radar. Once they got close enough, their own radar would pick up the German fighter, and they would switch to a standard interception. The psychological effect on the German night fighter crews was devastating. They were the hunters, the masters of the dark skies over their homeland. Suddenly, they were the ones being ambushed, shot down out of the blackness by an unseen enemy. They were being beaten at their own game. Surratt was a prime example of the electronic warfare arms race. It was a constant cycle of measure, countermeasure, and countermeasure. And with this new technology, the RAF was proving it could not only defend its own airspace, but could also achieve superiority in the enemy's. By 1942, the Germans were no longer playing catch-up. They were in the game. Their own airborne interception radar, the Fuji 202 Liechtenstein BC, was now being fitted to a growing number of their night fighters. It was a decent piece of equipment, operating on a much higher frequency than the British AI Mark IV, which gave it a more manageable antenna array that looked like a set of strange, branching antlers on the nose of the aircraft. The German crews, flying aircraft like the Junkers 88 and the Messerschmitt 110, became increasingly effective. They developed their own system of ground control, the Himmelbett, four-poster bed system, which created a series of defensive boxes across Germany, each controlled by a ground radar station that would guide a single night fighter onto a single Allied bomber. The night skies over Germany became an electronic battlefield. British bombers, flying in long streams towards their targets, would be tracked by German ground radar. The Himmelbett controllers would then vector their night fighters to intercept the stream. A German Ju-88 crew would be guided into the bomber stream and then switch on their Liechtenstein set, searching the darkness for a Lancaster or a Halifax. When they got a contact, they would close in for the kill. The German night fighter aces, men like Heinz Wolfgang Schnaufer and Helmut Lent, began to rack up huge scores, becoming heroes in the Third Reich. They developed deadly tactics, like the Schrägmusik, jazz music, an upward-firing cannon installation that allowed them to approach a bomber from its blind spot underneath and tear it apart with a single, devastating burst. This was the new reality of the air war. The secret British weapon of 1940 was no longer a secret, and the technology was no longer exclusive. Both sides now had eyes in the night. The war in the dark had evolved from a one-sided hunt into a deadly duel between two evenly matched, technologically advanced opponents. Success now depended not just on having the technology, but on who could use it more effectively, who had the better tactics, the better training, and the nerve to prevail in a high-speed, three-dimensional game of chess played out in total darkness, miles above the earth. Words and anecdotes can tell a story, but numbers reveal the brutal truth of the campaign's success. Let's look at the statistics. In the early days of the Blitz, from September to October 1940, the RAF's night defenses were almost non-existent. For every 1,000 sorties flown by German bombers, the British managed to shoot down only 2. That's a loss rate of 0.2%. For a German bomber crew, A mission over London was statistically safer than crossing a busy street. The psychological impact of this was immense. Britain felt defenseless. Now, let's fast forward. By May of 1941, after the first wave of Beaufighters with AI radar had been deployed and their crews had gained experience, the picture had changed dramatically. The German loss rate on night raids had soared. On some nights, it reached 7, even 10%. For an Air Force, a sustained loss rate of over 5% is considered catastrophic and unsustainable. The Luftwaffe could not afford to lose experienced crews and expensive aircraft at that rate. The numbers tell a clear story. In September 1940, night defenses shot down 37 German aircraft. In April 1941, that number was 96. In May 1941, it was 102. The single deadliest night for the Luftwaffe was May 10, 1941, when a massive raid was launched against London. The now veteran night fighter force was ready. They shot down 24 bombers in a single night. This had a profound effect on the morale of the German air crews. The darkness was no longer their friend. It now concealed a deadly, unseen enemy. They would take off from their bases in France, and as they crossed the English coast, the tension would ratchet up. They knew that at any moment, a stream of cannon shells could erupt from the blackness. The fear of the Nachtjäger, the night fighter, became a constant companion. At the end of May 1941, Hitler and Göring made a fateful decision. They called off the Blitz. The bulk of the Luftwaffe was transferred east for the upcoming invasion of the Soviet Union. While the invasion of Russia was the primary strategic reason, the unsustainable losses inflicted by the RAF's night fighters were a major contributing factor. The useless radar system had, in less than a year, turned the tide. It had made the cost of bombing Britain too high for the Luftwaffe to pay. As the strategic focus of the air war shifted from the defense of Britain to the Allied bomber offensive against Germany, a new problem arose. The Germans had developed a highly effective, radar-based air defense system. Their Freya and Würzburg ground radars could detect incoming bomber streams from hundreds of miles away, and their Liechtenstein-equipped night fighters were taking a heavy toll. The Allies needed a way to blind the German radar. The solution was breathtakingly simple and devastatingly effective. It was codenamed Window, and it consisted of nothing more than bundles of cheap aluminum foil strips. The idea came from a British researcher named Joan Curran. She calculated that if you cut the aluminum strips to a specific length, half the wavelength of the German radar, they would resonate and reflect radio waves, creating a massive, false echo on the radar screen. If a bomber dropped thousands of these strips, it would create a huge cloud of reflective material, a ghost signal that would completely overwhelm the German radar displays. The operators on the ground would see their screens dissolve into a snowstorm of static. They wouldn't be able to distinguish the real bombers from the thousands of false echoes. The German night fighters, guided by this ground radar, would be sent on a wild goose chase, hunting clouds of aluminum foil while the real bombers flew past untouched. The British High Command was hesitant to use Window at first. They knew that once they used it, the Germans would quickly copy it and use it against them. It was a double-edged sword. They held it in reserve for a moment when it would have the maximum impact. That moment came in July 1943, during a massive series of raids on the city of Hamburg, codenamed Operation Gomorrah. On the first night, the lead RAF bombers began dropping bundles of Window. The effect on the German defenses was immediate and catastrophic. The entire radar network was paralyzed. GCI controllers stared in disbelief at their screens, which were completely saturated with false signals. Their night fighters were rendered blind and useless. The raid was a horrifying success, creating a firestorm that killed over 40,000 people. But from a purely military perspective, Window was a triumph. The bomber loss rate on that first night was incredibly low. The balance of power in the electronic war had once again shifted dramatically, all thanks to a simple strip of aluminum foil. For nearly 2 years, the secret of airborne radar had been one of the most closely guarded assets of the war. But it was inevitable that, sooner or later, the secret would get out. That day came on April 30th, 1942. A Beaufighter from No. 255 Squadron was on a routine patrol over the coast of occupied France when it developed engine trouble. The pilot, Flight Lieutenant Alfred Moth Metherell, did his best to make it back to England, but the second engine failed. He was forced to make a crash landing. By a stroke of terrible luck, he put the plane down, relatively intact, on a field in France. Metherell and his radar operator, Sergeant W.J. Bill Drummy, survived the crash and were immediately captured. Crucially, they had been unable to activate the self-destruct charges for their AI radar set. Within hours, German technical intelligence officers were swarming over the downed Beaufighter. It was the jackpot they had been dreaming of. They carefully dismantled the radar equipment and transported it back to Germany for analysis. For the first time, they could see the inner workings of the technology that had been tormenting their bomber crews for so long. The German scientists were impressed. The British Mark IV set was, in their view, a rather crude piece of engineering, operating on what they considered a primitive low frequency. But they couldn't deny its effectiveness. They now understood the cat's eyes mystery. The interrogation of the captured crew confirmed everything. The Germans finally had their hands on the weapon that had defeated the Blitz. But did it matter? In some ways, it was too late. By mid-1942, the Blitz was long over. The air war had moved to Germany, and the British were already introducing more advanced, higher-frequency radar systems that the Germans now had to try and counter. Capturing the Beaufighter certainly accelerated the development of German radar technology and their understanding of British tactics. It helped them to refine their own Liechtenstein system and develop better defensive strategies. But the strategic surprise, the war-winning advantage that the AI radar had given the British during the dark winter of 1940 and 41, was a chapter that was already written. The secret was out, but it had been kept long enough to do its job. What became of the men who gave the RAF its nighttime eyes? Theirs is a story of unsung genius. Robert Watson Watt, the father of radar, was knighted for his work and continued to be a leading figure in science and technology after the war. His vision had saved Britain. But the man who performed the impossible task of shrinking radar into an airplane, Taffy Bowen, had a different path. After his crucial work on AI radar, he was sent to the United States in 1940 as part of the Tizard mission, a top-secret delegation that shared Britain's most advanced military technologies, including the cavity magnetron, the key to powerful, compact microwave radar, with the Americans. This act of scientific sharing was one of the most important decisions of the war, kickstarting the American radar program and laying the groundwork for Allied technological superiority. Bowen's work at the MIT Radiation Laboratory was instrumental in developing the radar systems that would help win the Battle of the Atlantic against the U-boats and give Allied bombers the ability to see targets through clouds. After the war, he moved to Australia, where he became a pioneer in the new field of radio astronomy, using the principles of radar to look not at enemy aircraft, but at the distant stars. He used his expertise to build giant radio telescopes, opening up a new window on the universe. The legacy of these boffins is all around us. Their wartime work on radar and microwave technology didn't just end with the fall of Berlin. It directly led to the development of modern air traffic control, making safe global air travel possible. It led to weather radar, which saves countless lives by tracking hurricanes and storms. The cavity magnetron, the device that made powerful airborne radar possible, was later adapted by another engineer who noticed it melted a chocolate bar in his pocket. The result was the microwave oven, now a fixture in kitchens around the world. These men, working in secret in drafty huts and cold laboratories, didn't just create a weapon. They triggered a technological revolution that continues to shape the modern world in ways they could have never imagined. So, how did a technology that the Germans considered years away, a system dismissed as crude even after they captured it, manage to shoot down over 600 enemy bombers and fundamentally alter the course of the Second World War? The answer is that it was never just about one piece of hardware. The useless radar was only one part of a revolutionary system. It was the combination of the AI radar in the air with the GCI radar on the ground. It was the fusion of that technology with the right aircraft, the powerful and rugged Bristol Beaufighter. And, most importantly, it was the integration of those machines with the right people, the methodical pilots and the sharp-witted radar operators, trained to work together as a single, lethal entity. It was a victory of systems thinking. While the Germans often focused on creating single pieces of exquisite, high-performance technology, the British excelled at building integrated systems where the whole was far greater than the sum of its parts. They also had the advantage of desperation. As an island nation under direct attack, their survival depended on defensive innovation. This spurred a culture of creative, pragmatic problem-solving, embodied by the Boffins, who were given the freedom and resources to pursue their seemingly impossible ideas. The story of airborne interception radar is the story of how a nation, with its back against the wall, used its scientific ingenuity to conquer the dark. It turned the night from a cloak of terror into a hunting ground. It proved that in modern warfare, the decisive weapon is not always the one that creates the biggest explosion, but the one that allows you to see your enemy when he cannot see you. It was the quiet, electronic triumph that saved a city, defeated an air campaign, and laid the foundation for the electronic world we live in today. The German pilot in his doomed Heinkel, wondering what phantom had struck him from the void, had no way of knowing he was one of the first casualties of an entirely new age of warfare.